Good morning, ladies and gentlemen. Welcome to your lesson this morning on energy. We're going to be looking at how to calculate it and several other things. Let's get started. Welcome to What's Your Question? For your starter then, I'd like you to have a go at the two questions I've placed here. You should name the 8 different energy stores, as there are 8 different ways we can store energy, and the 4 ways we transfer energy between those stores. Anything you can remember, please write those down on a bit of paper, and then when you finish that, you can then move on to the next section. I'd pause it here so you can move on in a second. Off you go. I've placed the answers to the starter then here. The different stores of energy are kinetic or movement energy, gravitational potential energy, or the energy in things that are off the ground, of elastic potential energy, the energy in things stretched or twisted. We have electrostatic energy, the energy in attraction between things that are oppositely charged. Chemical energy is the energy stored in chemicals. Nuclear energy is the energy stored inside the nucleus of an atom. Thermal or internal or heat energy is the energy stored in things that are hot. And magnetic energy is the energy stored in things that are attraction because of their opposite poles. Those different energies are how energy is stored, so they're not different types, they're just different stores of energy, and energy is transferred between those stores by one of the 4 different transfers: mechanical, heating by particle, radiation, or electricity. Mechanical is just you physically doing something to transfer it. Heating by particle is if it's transferred by conduction or convection. Radiation is if it's transferred by an electromagnetic wave, which we've talked about, like light or infrared or UV or gamma rays or things like that, anything in the electromagnetic spectrum. It does also include sound, and also electricity is the final transfer as well. Okay, the objectives for today's lesson then are placed here. We're going to recall how energy is transferred in a system. We're going to calculate energy stored as elastic potential energy. We're going to calculate energy stored as gravitational potential energy, and we're going to calculate energy stored as kinetic energy as well. Let's go. Okay, so your first activity then I've placed here. You need to describe the different energy transfers that have happened in these 4 different situations. Okay, the way you word this is really, really important. You need to make sure that you're saying what energy store is going to decrease, how will the energy be transferred out of that store, and which energy store or stores will increase. And using the words, the energy store will decrease to start with, it's transferred by this one, and the energy stores here increase, is really, really important. Your only real job here is picking out which different energy store you're talking about, because those 3 words, decrease, transfer, increase, are going to stay the same in any descriptions you do of this. Okay? So if I was to take an example of this and say, I don't know, like a hairbrush, and I was to throw the hairbrush in the air, as the hairbrush was moving upwards, my kinetic energy in my hand is going to decrease because of my hands pushing the hairbrush upwards. The mechanical energy would be how it's mechanical transfer is how the energy would go from the kinetic to the hairbrush, and I'd be increasing the kinetic store of the hairbrush. As it does that, I'm also going to be increasing the gravitational potential energy in the hairbrush. And when I let go, that kinetic energy is going to start to decrease also. The 4 questions here are what I'd like you to have a go at. Please pause the video here, write down what you think the answers are, because I want you to send that to me at the end of the video. There's also an extension there you could have a go at as well, don't forget about that one. Okay, so the answer to these 4 questions then. The first one was our electric kettle with boiling water in it. The chemical store is where that's going to start off, because if we're making electricity, remember, energy is stored inside the fuels we burn or the fuels we use to make that electricity. We know the transfer is going to be electrical, and we know it's going to be stored as internal or heat or thermal energy inside that kettle. In terms of an object projected upwards, much like with the hairbrush I described, we're going to start off with a kinetic store of my hand, decreasing. We're going to say that the transfer is by mechanical, because I'm pushing that hairbrush upwards, and this gravitational potential energy, as it's getting higher, is going to increase, and until I let go, the kinetic energy is going to increase as well. But the gravitational potential energy is the important one for you to mention there. An object accelerated by a constant force, you will need to talk about there being, again, chemical store, because if we're talking about, for example, a car, it's going to be burning the fuel of some way to provide that forward force. It's going to be transferred by mechanical transfer, and the kinetic energy is what's going to be increasing. So chemical decrease, transfer by mechanical, kinetic energy decreases. And then finally, a vehicle slowing down, we have kinetic energy is going to decrease because obviously it's going to stop moving as quickly. We're going to transfer that by mechanical because the brake's going to have to put a force on the tyres, and that's going to be increasing the thermal store in those tyres, because we know that when friction happens, heat's going to increase in those different places. Tick the ones you've got right, please, and I'll need to look at those when I go through the answers. The next three sections of this lesson are all calculations. Now, in exams, in your GCSEs, it's really important that you are making sure you do the following four things. You include the formula, the number, the answer, the units. Those four things are going to get you top marks in any calculation question that you get. If you don't write those four things down, you may miss out on answers. I'll explain what I mean by those things in a bit more detail. You must include the formula. That does not mean write a triangle and make sure you just put the triangle in place, because that's not worth any marks. You must write out the formula. For example, gravitational potential energy equals this times this times this, or this times this divided by this, whatever the answer is. You must write it out in like a sentence structure. It cannot be in a triangle. You can use the triangle to help you rearrange it, but you must write down the formula properly. So you need the formula for 1 point in your exams. You'll also need to then put numbers into that formula, show what numbers you put where. Write it underneath the calculation you've written out so you can clearly see this times this times this, or this times this divided by that is what I've done. Even if you get the wrong answer, you can get marks for showing these working out steps. The third point is to write the answer down. Obviously, you need to make sure you try and write an answer. And finally, when it comes to that answer, make sure you look at the number of significant figures you're asked for if you're asked about it, and any ways you're supposed to write it. So if it's in standard form, make sure you write it in standard form. If there's anything else it asks you to do, make sure you do what it asks you in the question. So before you write your answer, I just skim the question again to make sure you're not going to have to do it in a specific way. And finally, to put the units to any numbers you've used. If you don't include units, you may lose out on a mark, especially if they have not given you the unit in the answer. You would then need to make sure that you provide it. Some questions specifically require that you give the units. Make sure you do that, please. The next objective for us to meet is calculating the energy stored as elastic potential energy. Now, to do this, you need to know the calculation for elastic potential energy. To calculate this, we do half times the spring constant. Now, the spring constant is just a number telling you effectively how stretchy a springy or stretchy object is, and we're going to multiply that by how much extension has happened to that object. If you've looked at the lesson on Hooke's law, you'll have looked at calculating spring constants, and you should be able to understand what I mean by that. When anything with a high spring constant is going to be anything with a high spring constant is going to be more difficult to stretch. In terms of the next part, we're going to multiply that by the extension squared, and I've placed that calculation here for you. Now, if we need to rearrange this equation, it's easy to group these things together. So we have elastic potential energy as one thing we're going to work with, we have extension squared as another thing, and we have half the spring constant as another. We can put those three things into the triangle, but you'd need to remember there is an extra step if you're calculating half the spring constant. And there's an extra step if you're calculating the extension, because our triangle will lead you to get the extension squared, and you'd need to get the square root of that once you've calculated the extension squared. And for the spring constant, once you've calculated half the spring constant, you have to double the answer to that question to work out exactly how much what the spring constant would be. The extension down there, send me your mnemonics, comment them in the video underneath. If they're good ones, they could be useful. Something like silly elephants eat proper easily. Something like that is a good one you can use to remember, but you can put any one you want to. The best ones, I don't know what I'll do. I can't send you a prize. Maybe I will. Spend 5 minutes having a go at the questions using that calculation. I've placed the triangle and the equation at the top for you to use. 5 minutes, 3 questions, give it a go. Okay, so I can't really do a pen and paper here in front of you, so I've recorded this short video for you to watch on the formula itself. So I'm going to move over to the video. You just need to watch and listen to what it says. So for the answer to the elastic potential energy calculation, then I'll put the triangle at the top, up at the top here with elastic potential energy. At the top of the triangle, half the spring constant on the left, and then the extension squared on the right. And I'll use the K because that's just generally what we do in science to represent spring constant, and the X to represent the extension. First one then was calculating the elastic potential energy, and that's going to be half times the spring constant times the extension squared. So I've done half times 15 newtons per meter times by 20 squared meters. The answer to that would be 3,000 joules if I did that on my calculator. That shouldn't be too difficult. The next one, I need to rearrange this equation. So for this one, I'm trying to work out the extension. So I'm going to do the elastic potential energy divided by half of the spring constant, and that's going to give me the extension squared. So I'll do the square root of that answer to work out the extension of my spring. So 1500 joules divided by half of 25, or 1500 joules divided by 12.5 would give me most of the way there. And then I do the square root of that answer to get 10.95 meters as my answer there. And finally, the last question, I'm trying to calculate the spring constant. So I'd have to rearrange this equation at the top to do the elastic potential energy divided by the extension squared, and I then double that answer to get what I'm looking at, which is what I've written here, 2 times the elastic potential energy divided by the extension squared. So it's 2 times 250 joules divided by 2 squared, which gives me an answer of 125 newtons per meter. If you do have any questions about that, throw the questions down in the comments, and I'm happy to answer anything you want to know. Great. Right. So you've been through the answers there then. Next. The next slide you need to look at is this one. In this one, we're calculating the gravitational potential energy in something. We know, we've already said in this lesson, that gravitational potential energy depends on how high above the ground something is. The higher it is, the more gravitational potential energy it's going to have. So we're going to see height in here. We're going to see gravity in here, because that's obviously gravitational potential energy links directly to the amount of gravity. And we're going to see the mass of an object, because we know that the mass of an object affects the amount of gravity affecting it. Oh, no, it's not true. We know that the amount of mass an object has means that it's going to have a higher overall force pulling it towards the ground, so that needs to be taken into account. The actual calculation you need to do is gravitational potential energy equals the mass times gravity times height. Again, we can rearrange this. It gets more complicated if you're trying to calculate gravity, if you haven't rearranged things before. So putting it into a triangle like this can be really, really helpful. Again, if you cover up the thing you want to know, it tells whatever's left, tells you what you need to do. So if I was to cover gravity, I'd be left with gravitational potential energy divided by mass times height. And that's exactly what we need to be doing to calculate that. Okay, so cover the thing you want, and whatever's left over, that's what you need to do to calculate it. Again, there are 4 questions here. I'd like you to have a go at those 4 questions and make sure that you put these things in the correct units when you do these calculations. Mass must be in kilograms, gravity must be in newtons per kilogram, and height must be in meters. And obviously gravitational potential energy must be in joules. Don't forget, if something's in centimeters, you need to divide it by 100 to get it into meters. If it's in grams, you need to divide it by 1,000 to get it into kilograms. 5 minutes, write down the answer to the questions you got there, and we'll come back to it in a bit. Okay, the final. Okay, so I can't really do a pen and paper here in front of you, so I've recorded this short video for you to watch on the formula itself. So for the gravitational potential energy questions then, I've done a similar thing as before. I've got the gravitational potential energy up at the top of the page, the calculation with GPE at the top, m times g times h at the bottom. I've written that out for the first question, and I've put the numbers in, 50 times 10 times 20. The answer to that question would be 10,000 joules. I need to make sure I've given all the units, which I have. So that's my answer there. For question 2, I've got the gravitational potential energy is the mass times the gravity times the height. I've got 60 kilograms is my mass times 10 newtons per kilogram, because we're on Earth, and times by 1,000 meters, which should give you 600,000 joules. Should be your answer to that one. The third question, we rearranged that because we want to calculate height. So we did the gravitational potential energy divided by the mass times gravity. and that's going to give us an answer of 1.075, because we will have done height we're calculating there. We've done 430 joules divided by 40 kilograms times 10 newtons per kilogram to get that one. And the final question, we were trying to calculate the mass. So we covered up mass. We did gravitational potential energy divided by gravity times height. It's got 20 centimeters as its height, so we convert that into meters by dividing by 100. And that means that we then have got to put 430 joules divided by 10 newtons per kilogram, because we're on Earth, times by 0.2, which is our height, which should give us an answer of 8.6 kilograms. We can tick off all our units because we've included all of those things as well, and that would get you full marks on that question. Right, so you've been through the answers there then. Next. The calculations you need to do today is calculating kinetic energy. Now, the actual calculation to this is fairly similar to that for the spring constant. For the spring constant, we had half the spring constant times the extension squared, and for the kinetic energy, we have half the mass times the velocity squared. There's no reason why the rearranging of these won't be fairly similar. So again, we're going to group half mass, and we're going to group extension squared, velocity squared, sorry, together, and we're going to have kinetic energy as the third thing, and we're going to smash those into a triangle that looks like this. And then we need to remember that if we want to calculate velocity, for example, we'll do kinetic energy divided by half the mass, and that will tell us the velocity squared, and we'd need to do the square root of that answer. Don't forget, whenever you're doing these calculations, to make sure you write out the formula, the number, the answer, the units. It's really, really important. You have 5 minutes to have a go at these 4 questions, and then we'll go through the answers to these as well. And there's a little extension down there for you to have a think about as well. Please make sure you write these down, and make sure you're putting in the formula, the number, the answer, the units as you do these. Again, I want you to send me these at the end so I can have a go at marking and reading through what you've written. Make sure you can understand. Okay, so I can't really do a pen and paper here in front of you, so I've recorded this short video for you to watch on the formula itself. So I'm going to move over to the video. You just need to watch and listen to what it says. Okay, so I've pre-written out the answers to these questions just to make it a little bit quicker for you. So you can still see I've got that calculation at the top with KE for kinetic energy, half times M for the mass, and V squared for the velocity. For the first question, I've written out the correct formula. Kinetic energy is half times mass times velocity squared. I've put the numbers in, half times 50 kilograms times 40 squared, and that should give me an answer of 40,000 joules. I can tick off my units because I know I've included those. For the second question, I was calculating the kinetic energy, and 1,500 grams of an object is moved with a velocity of 5 meters per second. I had to convert that 1,500 grams into kilograms by dividing by 1,000, which is how I got 1.5 kilograms, multiplied by 5 meters squared, and then times by half. That should give you an answer of 18.75 joules. That's that one. It should be an 18. Handwriting's appalling there. The third question was to calculate the velocity of an object with a 4,500 kinetic energy and a mass of 30 kilograms. So work out our velocity then. We do the square root of the kinetic energy divided by half the mass. That's the square root of 4,500 divided by half times 30 kilograms. Half of 30 kilograms is 15, so it's 4,500 divided by 15, and the square root of that answer, which should give you 300 before you square root it, and then 17.32. I wouldn't go any more than 2 decimal places on any of these questions, because you don't need huge strings of numbers as well, and that's going to be a velocity, so it's in meters per second. And then the final question was to calculate the mass of an object travelling at 40 meters per second with 2,000 joules of kinetic energy. So we again have done 2,000 joules divided by 40 meters per second, because we rearranged that equation here. Kinetic energy divided by velocity squared, and then doubling it, because that gives us half the mass. So 2 times kinetic energy divided by velocity squared. So 2,000 joules divided by 40 squared times by 2 should give you 2.5 kilograms. We can tick off all those units. We've definitely done those things. Great. Right, so you've been through the answers there then. Next, exactly what it is you're doing. Off you go. Okay, so the final thing for you to have a go at today is this 6-mark exam question that I've placed here. It's all about a roller coaster, which is why you can see a roller coaster, and it describes a roller coaster. Anyway, Kylie and Laura ride in a roller coaster car. The diagram shows the girls in the roller coaster car at the end of the ride. Laura has a mass of 80 kilograms and Kylie has a mass of 40 kilograms. Kylie's height above the ground at A is 31.25 meters. Because she's halfway down the slope here, her kinetic energy is equal to her gravitational potential energy. Whatever one is, the other will be the same. Her acceleration due to gravity at this point is 10 meters per second squared, because that's the same as her force of gravity acting upon her. And your job here is to describe the difference between Kylie's kinetic energy and Laura's kinetic energy at A, and to use the information about Kylie to calculate her velocity at A. It's a 6-mark question, so we need to make sure that we do the following 4 things. We want to decode the question, so we know what we're being asked to do. We want to plan an answer to the question. We want to write an answer, and we want to go back and check we've done all 4 of those different things. Here, I have decoded the question for you, just to give you an idea of what we're looking for when we decode. I've highlighted all the numbers that we need to work with in green. So we have 2 masses, and we have a height that we can use. And we then have the command words highlighted in yellow, and then the important information you need to know of as well. Other than that, I've highlighted in purple. So to start off with then, you should be planning what you need to do next. We need to make sure we describe the difference between Kylie's kinetic energy and Laura's kinetic energy. So we need to talk about the difference between those 2 things. But our first point then is to make sure we make a statement about how those 2 things are different. That may be just you describing the size of one, the size of another. You can use numbers to do so. Or you can describe a relationship or a pattern. Now the pattern in the difference between them is better. So is it one double the size of the other? Is one half the size of the other? Is one triple the size of the other? Anything like that would be really, really good. You can calculate that because we have got her mass and their height at A. We've got their mass at, in the question. We've got their height of 31.25 meters. And the only other thing you need to work out their gravitational potential energy is their gravity, which we know on Earth is 10, and we know that those 2 things will be the same. So you should be able to work out what their kinetic energy is and compare them quite easily. The second thing to do is to then calculate Kylie's velocity at point A. To work out her velocity, we know we need to know her mass, which we've been given, and we need to know her kinetic energy, which we've already said we can calculate. So we need to make sure we then calculate her velocity at A and give an answer, making sure we write out the formula we're using as we do those things as well. The extent you need to think about if you finish that as well is that energy transfer always going to be at 100%? Will it always be transferred from one place to the other? And if not, where does the extra energy go? Have a go at writing that down as well. I want you to send me your answers to this slide. I want to see what sort of things you wrote and whether you all managed to have a go at doing the calculations. Pause the video here and have a go at answering those questions. Or that question. Right, okay, so we need to then talk about, first of all, the differences in kinetic energy they have. So, there are 3 things that can affect the amount of energy they have because of where they are. And those are going to be either their mass, which comes up in both the equation for kinetic and the gravitational potential energy. They're going to be their height, which comes up with the equation for gravitational potential energy, and they're going to be their velocity, which comes up in their calculation for kinetic energy. We know that they are both at the same height at this point because they're both on the same roller coaster ride and they're sat next to each other on that roller coaster ride. We know that they're both traveling at the same velocity because, again, they're on the same roller coaster, so their velocity is not going to be any different, which means the only thing left over that we need to talk about here is the mass of these 2 different people. We know that Laura has got more mass than Kylie does. We know that if she has more mass, she is then going to have a higher kinetic energy as well. We don't just know that also, we also know that because her mass is double that of Kylie, she is likely going to have double the amount of kinetic energy that Kylie has as well. We also know that if we're going to calculate her kinetic energy, which is the second thing we need to do here, we are aware that the kinetic energy is equal to the amount of gravitational potential energy that they have. There are two ways we can work out their velocity. We can use the correct mathematical way, which is by using the algebra and breaking the two equations down and the way they link together, or we can just work our way through both equations separately. I'll show you how to do both. Okay? First of all, when it comes to using the correct mathematical way of doing this, we would first of all show the kinetic energy and gravitational potential energy equations next to each other. So that's mass times gravity times height would be equal to half times the mass times the velocity squared. Now both those equations contain the mass. Because of this, we can cancel those two things out. That leaves us with half times velocity squared equals gravity times height. We then need to make sure that we're going to undo the halving, which we have left over there. So we're going to need to double the gravity times the height. And then we're going to also need to square root our answer to finally find out what we need to do. So the final equation you need to use as the velocity is the square root of 2 times gravity times height. So we know that gravity on Earth is 10, and we know their height is 31.25 meters. So we do the square root of 2 times 10 times 31.25, which would get you 25 as your velocity, so 25 meters per second. The other way of doing this is first of all working out how much gravitational potential energy they have, and then from that working out how much velocity they have. So we'd need to do the mass times the gravity times the height. We know the mass is 40 kilograms. We know the gravity is 10 newtons per kilogram. We know the height is 31.25. This should give us an answer of 12,500 joules for how much energy they have at this point. We can then use that as our kinetic energy, and our rearranged kinetic energy equation for velocity is going to be the square root of the kinetic energy divided by 2 times the mass. So that's the square root of 12,500 divided by 2 times 40. If we do that, again, we should end up with an answer of 25 meters per second. Here you can see how the marks are allocated in this question. You know that at level 1, you're describing the differences in their kinetic energy, or you're attempting to calculate the velocity by using the equation. So that's you mention the equation in some way, you're attempting to use it. As long as you've attempted to use it, you're going to get 2 marks in this question. As long as you've described the difference in their kinetic energy, you're going to get 2 marks. For 4 marks, you have to do both those things. Again, you haven't got to get your calculation right, but you do need to describe the differences in kinetic energy correctly at that point. And then for level 3, you must do both those things and you must correctly calculate the velocity at the end there. If you don't manage to do that, you're not going to get those final marks. That's the end of the lesson for today. I'd like you to send me the answer you wrote for the 6-mark question, and with if you make it as big as possible, how many marks you think you got on that question, that'd be great. And then I can see how you're all getting on with that as well. I'm going to be making more videos like this over the next few weeks while we're out of school. If you want to pay attention to those, feel free to like and subscribe to this video and to my channel, and we can watch some more. Great. Thank you.